what you have learned, which is first in your rules of Boolean algebra. Can you see my screen now?
Yes, doctor.
Yes, ma'am.
Okay, thank you for answering. So over here, you already learned 12 Boolean algebra. And after these rules of Boolean, you need to have another one which is called as Morgan theorem. The Morgan theorem. So I promise that I'm going to touch this subtopic, but I think I had skipped it and I directly go to the POS and SOP. So now today, I want to touch about this because it's very important for you in simplifying your Boolean equation. It's only simple theory, and you just need to remember two. I think over here there is two theorem only. So quite simple, only one. When you want to apply it, you need to have a skill. So you cannot just depend on this simple equation without any exercise. So go back to the exact pages. So in your De Morgan theorem, it is needed for you to minimize the variety and also number on your logic gate. So there is two. First, you need to simplify your Boolean equation. And another one thing is when you want to simplify your logic circuit. So normally you're going to have a combinations of logic gate for your circuit, but you need to simplify it. Another one is you're going to have a long Boolean equation, but that's why you need to simplify it using your 12 Boolean rules and also the Morgan theorem. So if you check over here, you have the AND gate, which is X and Y as the input, and your output will be X dot or multiple Y, and then you will be having a bar. How are you going to simplify it? You will use the first theorem, which is xy bar equal to x bar plus y bar. It's also similar if you're having a, b. This one is multiple bar. You're going to simplify it using first De Morgan theorem, DM theorem. You will get this a bar plus b bar. So as mentioned, x and y can be replaced with any variable from A to Z. And let me, sorry, because this is the video. This is our turn to present for the conference. Okay, wait for a while. I want to record first. Okay, continue. So the second one is, sorry, for the no gate, which is negative n. So it equal to negative n. who joined this class. Wait, I need to accept. So from here, if you have the no equation, let's say you have x and y as the input, and also x plus y bar, it will be equal to x bar y bar. So you also can have like a b, sorry, you have all the bar like this, and it will be equal to x bar dot y bar. So you need to memorize only these two theorem. First theorem is xy bar equal to x bar plus y bar, and the second one is x plus y bar. You will be getting the x bar y bar. So please make sure you draw this thing carefully. So because sometimes you are mistaken for both of these. So this is totally different. So for me myself, I will just draw it and make it space. So we can see there is a huge difference between these two. So this one is not similar to this. Okay, so please make sure you can see there is a gap between on this bar. So on the theorem first, which is if let's say you have the 3 variable, and this one if you have 4 variable, it's just similar only on how you're going to apply the first theorem. If you have this multiple bar, you will get the adding bar over here. And the second one is also similar. It's only different on the variables, whether it is 3 variables and also 4 variables or etc. So if let's say you were given this equation, so you're going to be simplify it. So first of all, you can see there is a bar, and over here it is dot or multiple. It represent as this one is x, or and also this one is y. So if you have x dot y bar, so you will be using the first theorem, you will get x bar plus y bar, isn't it? So that's why this x, you will put it here. And this y, you will put it here. That's why you get a, b plus c bar plus a plus b, c bar. This is just directly convert from this equation to simplify it similar to this using the first rules of the De Morgan theorem. Then after that, you will apply your 12 rules of your Boolean algebra rules. So you're going to simplify it that a, b plus c, it is, you can see the, oh, sorry, still using the De Morgan theorem, a plus c, you can see over here, it is similar to the second De Morgan theorem. This one is x This one is y. So from here, you will get AB plus C. If you have this one is your x. This is your y. So you make it similar to AB bar dot C bar. So that's why you will get like this. Similar also to this one is representing as x. This is representing as y. Then you convert it into this equation from your De Morgan theorem rules number 2, sorry. So after you simplify it to this step, you still can simplify it because there is another equation that you can apply the De Morgan theorem or DM theorem. So you can see over here, this one is represented as x. This one is y. As I mentioned, x, y is depend on you. You can have many variables from a until z. So it's depend on the equation. I just showing this as x and y because this were given in the first slide over here. So don't want you to make it to be confused. So similar also this one, this is x. This is also y, and you replace it, you will get like this. So please remember the first theorem and second theorem. So this one is self-test. You can try to prove the A bar equal to A bar, B bar. So using the truth table. So you can see over here, if you have the input A, B, you can also have the truth table. So A bar, B bar, so you can see it clearly. If A0, A bar will be 1. Simple also similar to B. If you have 0, you will get also 1 over here for B bar. So please try to look into this AB as your output. So from AB, A dot B, you know it is AND gate. So if AND gate, if you have A and B, you will get 0 over here because you only will get 1 if both input is 1, isn't it? So how about A bar, B bar? For A bar, B bar, you will get, you will look into these two table row. And similar also, if you have the input is 1, then you will get 1. So over here, this is 1. And how about this one? So you can see it is a NOT or converter from AB. So you convert it, you will get 0 to 1, 0 to 1, and 1 to 0. So you are needed to approve whether A bar, this one, and A bar, B bar, is it equal or not? So now you can see that it is totally not similar, isn't it? So that's why I mentioned for you. What you said. Sir, I'm very sorry, but could you say that again? Okay, this is the answer. Now you have several exercise, which is I want to recommence to the presentation. Suddenly My battery is finished for my phone. Give me a minute. Sorry, because I have 2 parallel session today. I got conference and I got class. And tomorrow also I think I have supervision class. So I don't know what happened. I still need to wait for the organizer to inform. So over here, I continue. There is exercise. Please try to do it because this one is just a simple. You can just apply it. I show you first example is A. You can see that there is a dot over here. You cannot take this to apply your second theorem because you can see over here the bar is for all. So mean that you need to apply the first De Morgan theorem. So after that, you can see over here, this should be a multiple. So you will multiple this as x and this one is y. So your x will be a plus b plus c. And then you will get like this bar. This one the bar. Oh, where is the conference? Wait for a while. I want to re-enter the conference. It's my student turn, but I hope it's not finished yet. Suddenly when my student want to answer, I was logged out.
Your experiments for communication underwater, this was the best to use for communicating a signal. Could you give some advice on that? So, yes, the water is very, very important. It is different from the land parts of land is different. So we use signals.
Okay, I already entered. Sorry, again and again. Okay, now back to the example number A, which is the example 1. So you can see over here, as I mentioned, this one you cannot apply for a second theorem because you can see that your bar is for all from this until here. So if you want to apply the second theorem, it will be until here only. Yes, who called me? Okay, then there is too many interruption.
Are there any other questions from the audience?
And over here, you can see that it's from here until here. It means that you will use the first equation.
That was the last presentation for our
This
session.
one is multiple and you need to assume it to be x and then this is y. After that, after you're going to apply your first De Morgan theorem, you will see that you will make it bar and then plus, isn't it? So what you're going to have is A plus B plus C bar, and then you will have like this the bar. So please make sure you can separate it so you can see it more clearly. So after that, you can apply your second theorem. And then this one, you cannot simplify it more because this one is already simplified. And after that, you apply this, you will get this one is x, y, and then maybe this one is z. So that's why you will get a bar, and then you will multiple b bar and multiple c bar. And you plus it to be the bar. So later on, please try to do it by your own. I just show you a simple step on our De Morgan theorem. So I hope that I already cover it. Please make sure that whenever I did miss something, let's say just as this De Morgan theorem, I did miss it, please inform me because it's accidentally missed. I not purposely missed this De Morgan theorem because I thought after your rules number 12, I already mentioned in your video, you can check my video back, that I'm going to touch this De Morgan theorem, but unfortunately I directly go to the POS, isn't it? So I hope that you can try the De Morgan theorem, because if you're going to use your POS and also SOP, you also need this 12 roof and DM theorem for you to simplify your circuit. But after that, if you look and check my video, you will find out that there is new truth table called as K-map. This is very useful for you to just checking your answer. If let's say in your exam you were given with long equation, let's say A, B, until maybe you have 5 variables, so it's too long and you need to simplify it, and you don't know whether your answer, your simplified answer, let's say you get A, B bar, so you don't know whether this is the correct answer or not. You can use your K-map to check whether you are not been asked to use K-map and you just been asked to simplify the Boolean theorem or equation, not theorem, the Boolean equation. So you can use K-map to check your answer. So after this, maybe if you still did not finish watching my video, you can try to look. And I also already upload the second video. Let me go to the exact slide. So we already cover in our SOP and POS. And in the video, I repeat several times on the differentiation between SOP and also POS. Please take note it. And you also already learned on SOP. What is the important on SOP is you will apply the rules number 6 to simplify it, and POS you're going to use the rules number 8 and 12. So is it okay? This one, I hope that you already understand it. This one we already touched, and then this one is how you're going to convert using the SOP and also POS. Where is the different part? Let me go to the exact slide. Okay, this is the one that very important on SOP and POS. This one, I think it is a minimized version from all slides that touch on SOP and also POS. From here, from this slide, you can see all, which is first. And for your SOP, please make sure you remember that A equal to 1, A bar equal to 0. But when you touch on POS, you will notice that it is a vice versa from SOP. So A bar will be 1 and A will be 0. So if you wrong in this first differentiation between SOP and POS, so you cannot get the answer. So from here, another one is the output. For the output SOP, you will look into the output 1, isn't it? And for the POS, you will look into the output of 0. So that is the second differentiation between SOP and POS. Now, another differentiation between on how you're going to represent it. So the expressions of the boolean is going to look like this, which is on the multiple of your you have the term and you will add all your term. But for the pause, your term will be multiple. So in the expression also it's different. And another one in the notification, you can have the simplification or notification, but it will be different, which is sigma for SOP and pi for POS. Why you need this to be different? Why you don't just using the sigma or just pi for represent for both SOP and POS? Because it will be tricky for you to remember, isn't it? This is needed because if let's say you have only sigma, then maybe you can have this sigma and then you need to mention this is POSOP. So it's very hard to do that. So instead of having this, because it's just similar to this one, so you need to have a symbol, I think, a symbol to represent it to be SOP, and this one is symbol to represent is as POS. So once you see you are given the equation like this, you know, oh, okay, this one is SOP. So when you are given the pi, so you know it is POS. So it's simple for you to remember, which is you have two different on this side and another side which is on expression and also notification. Total all, you're going to have four differences between SOP and POS, the basic thing. So this I already touched all in your video. So I hope that you can check your videos, my videos, and then please try to do all the exercise by yourself first. And one more thing that I want you to know is on the notification. Where's my pen? If let's say you are given just this equation, you can see pi notification and you were given 743. So what is the meaning on this? So this one is decimal. So you need to convert it into this one is ABC, means that you have the variables of 3, which is A, B, and C. If you have 3 variables, you're going to use 2 the power of n. You're going to put is to the power of 3. You will get 8 possibilities for your input. So over here, the meaning of 7 is, this one is decimal, your input will be 1, 1, 1. How you get this 1, 1, 1 is converted into binary, from decimal to binary. 1, 1, 1 is equal to the input A will be 1, input B will be 1, and input C will be 1. Next is you have 4. Then what is this? It is a 1, 0, 0, isn't it? So this one is A, B, and C. So the output is A1, B0, C0. Another one is 3. From decimal, you convert it into binary, you will get 0, 1, 1. A, B, C. So as mentioned that you have 4 differentiation, and one of that is for SOP, your output will be 1. It means that you will get the output of 1 whenever you have this input, and this input. So you have 8 possibility. This one is only 3. So you have 3 output will be having 1, and another 5 will be having a 0. So you can draw your truth table. Let me show you 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. 0, 1, 2, 3, 4, 5, 6, 7. So this one is decimal, this one is binary for your input. So this one is A, B, and C. So this one is just to show you, please don't confuse. So whenever you have, this one is your output, whenever you have 7, means that 1, 1, 1, you will get 1 as your output. Another one is 4, you have 4 over, this one is 2, 4 over here, 1, 0, 0. So you will get 1, and then the 3 is here. So the rest will be 0. So this is for POS. This is for SOP, and then 0 will be POS. So using this one, you can get your equation. So I give you the example on equation. What you get is, as I mentioned, 1, 1, 1. So your X or your F, your output will be A, B, C. Plus, you have another one is 1, 0, 0. It means that A, B bar, C bar. Please make sure this one is odd. And plus, you have another one is 0, 1, 1. Means that A bar, B, C. This is the equation for SOP using the given pi notification. The rest you can also get your POS, which is there is 5. So I give you only another one, which is maybe over here there is 6. 6 means that 1, 1, 0, isn't it? This is represent as 6. So for your POS, you will get A plus, so don't make me confused. This one, 1 for POS, 1 is equal S bar. A bar, B bar, plus C. And then you will multiply it to another 5, another 4. Then you will get your pause. I think all I already touched in your video. Please make sure you check my video, and I also have another video after that. Only today I want you to focus on the first video. That's why I only upload the link to your e-learning for the first video. You just joined Dafa. So I hope that you understand whatever I teach. If let's say you didn't understand and have difficulty on the video or in your books, in your slide, please make sure you ask me directly. Is it okay or not? So any question? So if there is no question, I think only that for today. So I hope that we can meet again tomorrow. I will try to run the class, although I have supervision class tomorrow also. Is it okay? Okay. Thank you for your participant and have a good day. Bye-bye.
Thank you, Doctor.
Okay, bye-bye.
Thank you, Doctor. Thank you, Doctor.
Thank you, Doctor.
Weh Najib. Oi Najib. Najib.
Ha.
Okay. Okay, nak make sure tak tidur je.
Ada. Mana boleh tidur?
Ada. Weh, kau PM aku sekarang. Najib,
Kenapa?
PM aku.
Ya. Yeah.
Aku bagi link. Aku nak bagi link TikTok viral.
Ya. Yeah. Jap.
Jaza, are you there? Jaza,
Tidur.
tidur ni. Weh, Jad. Jad.
Dia record dah. Tak boleh tengok lepas ni.
Jib. Najib.
Ya, aku dapat.
Masuk.
Dah ramai dah. Bapak banyak.
Masuk. Bilik kuliah sekarang. Aku nak biar Syazah ni, biar record sorang-sorang. Mampus kau. Mati kau Syazah. Babwah. Bye.